Hello everyone, this side Rajan Singh and we are group 3 from Industrial Instrumentation Lab, and this video is all about our group project automatic smart car barrier system. This is basically a traffic control system that enhances our security, and this project is under the guidance of Rupam Gupta sir and the technical assistant Kailash sir and the Suraj sir.
So now we will jump to our working principle of project. So a smart car barrier system relies on an array of sensors like infrared and ultrasonic to detect the approaching vehicles. These sensors send data to a control unit which process the information based on the predetermined criteria. Such a vehicle authorization and safety protocol, the control unit make a decision to either raise or lower the barrier. Actuators which can be electric motors or hydraulic system then execute this decision by physically moving the barrier arm. Throughout this process, the system monitors the position and status of the barrier, ensuring the safe passage. Safety features like emergency stop and obstacle detection are often integrated for added security. So now we will jump to the component section which we have been used in this project. First one is ultrasonic sensor. There are two ends here. First one is transmitter end and second one is the receiver end. Transmitter end transmits the sound waves and it will collides with our object, and it again our reflecting from object there are reflecting wave which will receiver receive and send the data to our microcontroller. It will process the data and send the electrical data to our servo motor which will act as an actuator. Here the main work of actuator is it transfer the electrical energy to the mechanical energy. So let look at here. Here is our it is a car. It is receiving a data, receiving sound wave and transmitting the sound wave. It is sending the energy here, and look at here our the motor which is acting as an actuator. The microcontroller is sending data to our motor, servo motor, and it is controlling the physical arm, and hence it is going up, and let's suppose our car passes by, so it has come down.
Now we will take the overview of the code. First, we include the servo file and define the pins for LEDs like 2 for green LED, 3 for red LED, and 5 for 4 are for ultrasonic sensors pins. And there are some defined like a variable like centimeter, degree, flag, set timeout, 200 millisecond, and the main timer. These are the variable we have inside. Now this is our void loop. First, to set up the code for 9600 serial bit communication per second, and now we attach the 8 pin of the servo motor for as output and print, and this is my servo motor right analog function of the Arduino IDE that's an inbuilt in it, and this is a pin mode and function we have include like the LED output for output and the trigger pin for output and echo pin for the input. Now we go into the our for loop. There is we write the digital write function when the trigger pin is low. There is a delay of 2 microsecond, and the trigger pin is high, that the microsecond delay of 10 microsecond. And this is our include pulse Vico pin in height, that is a, and this is we have calculated the distance of the our obstacle in on the other side. They have if the if the distance is measured is less than is greater than 100, the physical arm of our is open from 0 to 90 degree, and the green LED is off and the red LED is off. And this is a loop we have sliced from 90 degree to 0. The 0 to 90 degree move of our physical arm, and then they take the some delay and again down at the 0 degree from the 90 degree.